Welcome back, guys. What's going on? Today we're going to talk about enumeration, but during the phase of post-exploitation. So as you know, guys, enumeration is a critical phase during any penetration testing engagement. So there are two stages where you will use enumeration during your penetration testing engagement. So basically, today's video will talk about the stage of post-exploitation, meaning it's the stage after you get access to your target. So what's the use of enumeration after we get access to the target? As you know, guys, so before post-exploitation, we have a stage called pre-compromise. So in pre-compromise, we still haven't compromised the target yet, meaning we still haven't got access to the target, meaning network or a single host. So we're in the stage of pre-compromise. So in pre-compromise, we want to use enumeration here, okay, in order to do what? In order to, first, we want to do info gathering. So gathering information about the target. This includes learning about the open ports, the running services, and we also want to know information about the IP addresses, subdomains. Additionally, we want to see the running services and applications. So we use enumeration in this phase because we want to gather information about these key aspects of the target. And the objective is to find a vulnerability or a misconfiguration. Once we do that, okay, once we find the vulnerability or the misconfiguration, we take advantage of this through the exploitation. Okay, now after we exploit the vulnerability or we take advantage of this misconfig, we get access to the target, and now we start the phase of post-exploitation. So the post-exploitation phase includes the actions we take after we get access to the target. So that's first. Okay, so what we want to do after we get access to the target? We have a couple options or couple scenarios. It depends on your goal. So we might be aiming to do credential harvesting, creds harvesting, meaning you want to dump the credentials of the high privileged users, whether root or system or other users. You might want to do data exfiltration. So basically, you find this sensitive information that the target stores and you transfer the information through maybe social media, or you tunnel it through DNS. Anyway, you do data exfiltration so that you get this information to your attacker machine or to your command and control server. So credential harvesting, data exfiltration. Additionally, you might want to do privilege escalation and persistence. So you might be interested in escalating to the highest privileged user, okay, root, or in Windows system, it is the system account. And then you want to maintain your access through the persistence. So you might be doing that through backdoors, or you could be doing that through maybe like startup scripts that connects, the startup script connects back to your machine whenever the system boots up. All right, so in order to achieve all of these goals, okay, we want to again do enumeration. Okay, so that is the purpose of enumeration here after the post-exploitation phase. Now let's talk about what are the things that we enumerate in order to achieve these goals: harvesting, exfiltration, privilege escalation, persistence. What are the things that we want to enumerate? What are the things we want to learn about the system in order to achieve these goals? All right, so after we get access to the system, we want to gather information about, first, the users. What are the users that exist on the system? In addition to the groups. So learning about the users and the groups enable us to understand what will be the target that we want to escalate the privilege into. So say you have discovered that there is low privilege user, such as maybe, let's name the user as, okay, my name. Okay, that's a user on the system. And you learn that there is another user called admin in addition to the root account. It happens that this user belongs to maybe the, let's say, admin groups, and that user belongs to admin group as well. And this is the root account. It doesn't matter which group, it's the root account, root group. So we want to learn these information because initially, when we get access after the exploitation, okay, most of the time you will get access as a low privileged account. What are examples of low privileged accounts? So low privileged accounts, mostly they are service account. So what are examples of service accounts? Service accounts handle services such as the web server service. It's handled by, in Linux systems, by data. In Windows systems, handled by the IIS user, Internet Information Service. And that's if we're talking about Windows Server, of course. Now, if it was regular Windows workstation, Windows 10 or Windows 11, it could be handled by the local user account. Another example of service account is a service account that handles the database. Database could be MySQL, so the account could be MySQL account. Now, when you if it happens that you have performed or achieved or exploited the target through one of these services, you will land on the machine as the web server account or the database account. Okay, now sometimes you get lucky and you get access to another type of low privileged account, which is local accounts. Now, not all local accounts are highly privileged. Some of them are created and used by regular users, but they don't happen to be admins. Okay, for example, a user who is part of the maybe IT group or the HR group or the finance group, they happen to log in to the current workstation to work on some files. So we create an account for these people. So basically, the account name could be any name, and they might be using SSH to log in to the machine and execute system commands or perform some operations on some files. Now, if you get lucky, you will get access to one of these accounts and you will have SSH access. Now, definitely local accounts are higher in privilege or have higher privileges than service accounts. Okay, so we want to gather information about the users and the groups in such a way, in this fashion. Another thing we want to gather information about is the applications installed on the system. Why? Because if we are able to learn the applications, we want to learn the version of these applications. Learning the version will enable us to go out and search for vulnerabilities. Okay, now if you exploited or if you find a vulnerability for one of these applications, you will be able to exploit it and have root access. Specifically, we'll perform privilege escalation in this case. And the privilege escalation doesn't necessarily lead to the root account. Now it could lead to, it could be horizontal and it could be vertical. And here it is vertical. Now in horizontal privilege escalation, you move from a low privileged account into a higher privileged account, but not necessarily the root account. Meaning, let's say you got access as the www data, the web server user on a Linux system, Apache server. Now in horizontal privilege escalation, you will escalate from www data into another local account, local non-root account. The local non-root account will have higher privileges than the web server user. Now in vertical privilege escalation, we escalate again, maybe from www data into directly to the root account. That's why we look for the applications and the versions in order to find a compatible vulnerability, and therefore we exploit the application and escalate the privileges. Okay, what are the other things we learn through enumeration when we get access to the system? After the applications and the users, we want to learn about the version of the kernel. So, meaning we want to learn two things: the OS name and the version. Why? Because there are things called kernel exploits. Kernel exploits exploit vulnerabilities in outdated OS operating systems. So when we learn the OS name and the version, we technically increase the vulnerability of finding an exploit for that version if it is outdated. Now sometimes we were not able to exactly find out the exact exploit or the vulnerability of the version, so that's why what we do here, we enumerate for the installed updates or patches. In Windows systems, we call these, so in Windows they are called hot fixes. Now learning the latest update that got installed on the system will give us an idea on about how a patch how well the vulnerability or the OS is patched. So basically, let's say the latest hotfix was installed in 2020. So if we search for vulnerabilities, okay, after 2020 that were specified for the OS we actually targeted, we'll be able to find exploits and therefore apply kernel exploits. Now in kernel exploits, when successful, it will directly lead to the root user of the system. So you will do privileged escalation. Okay, so why we always prefer to, after we get access to the system, we prefer to escalate the privileges, because when we escalate the privileges, we will have much higher success harvesting the credentials and exfiltrating the data. Because when you get access as a low privileged account, you might not be able to extract credentials or perform that exfiltration, and therefore you will not also be able to perform persistence. You will lack the necessary permissions on files and directories. That's why privileged escalation is a preferred step that comes after or comes post-exploitation. Okay, so enumeration of these key aspects of the target system will make the mission much easier to escalate the privileges. Okay, what are the other things that we can enumerate? We can look for configuration files. Config files. Why config file? Because usually config files have usernames, passwords, hard-coded passwords, API keys. So configuration files are a hot spot to perform credential harvesting and even escalate the privileges. Because if you find the username and password for a local account, you will be able to escalate from the service account into local account, and hopefully from local account into root. So that's another example. 6. Usually also we look for the maybe everything. Let's talk about every running processes and services. So why we also enumerate the running processes and services? So basically here, if we enumerate the running processes, we will get a list of the running programs, and we will also learn what are the users running these programs. So every process has a binary, okay, that runs this process. Now, if we enumerate the processes, we will find these binaries. And if this binary has improper permissions, you will be able to control the process and therefore run commands as the user running the process. So again, every process has a binary and user. Okay. Now, if you control the binary, because it might have improper permissions or suit bit set, we'll be able to control the process, and therefore if we control the process, we will be able to direct the process or control its behavior. So let's say we have a process that connected to, let's say we have a process called backup sh. This process is controlled by a backup script. Now, the backup script is run by a user called maybe let's say local account. Okay. Now, if the backup script has improper permissions, okay, what happens if it has improper permissions, meaning anyone can modify on the script, including the user that you got. So if you are able to modify the backup script, you'll be able to control the process, and therefore instead of performing backups, we will just choose whatever we want to do with the script, meaning we might be interested in instead of performing backups, maybe using reverse shell. So what happened when this backup script runs again, it will actually connect to the reverse shell as the local account. So when you set up a listener using netcut on your machine, let's say on port 4545 as I usually use, okay, we will make the backup script, and instead of backing up the files, we will make it connect to the listener here through a reverse shell, and therefore we will get another session to the machine as the local account, because it's the account running the process. Same with services. Services are run by binaries, and services has a wide array of methods to exploit. For example, there is something called the unquoted service path. In unquoted service path, what we do here, we create a binary, a payload that has the same name as the binary running the exploit, running the service. And then we will make the service run our own version of the binary, which will actually may connect to my machine on a different listener, or it may create persistence. It could be a backdoor. All right. So that's the role of enumeration here during the post-exploitation phase. Now it's time to convert this into a practical scenario. Okay, so the lab scenario of this video is taken directly from this room, enumeration in TryHackMe. This room is part of the red team track. The lab scenario of this room is 2 machines. First one is Linux and other one is Windows, and we'll perform the enumeration on these 2 machines. So here we are connected to the Linux machine, and now we want to start the process of enumeration. So basically we get access to the machine. We have a shell access. Now we start enumeration to learn more about the system. So first we start with the users. Who am I? So we are the user. We can also learn about the OS. So there are many commands we can execute to learn about the operating system. Okay, so let's start here with this one. So we can execute uname-a. As you can see, it is Ubuntu, and architecture is listed here. And to learn more about the version, we can use cat etc lsp-release, and we can see it's Ubuntu LTS, and that's the version of the operating system. Now you have learned the OS name and the version. You can now start looking for a vulnerability, or if there is a vulnerability for this version, and hence if there is a public exploitable match. Okay. Now this is the only way to learn about the operating system name and the version. Of course not. There are multiple commands we can execute, and generally it's better if we execute this command because different systems or different Linux distributions have different release files. So if we learn about the all the release files, we'll be able to learn about the version. So basically here the file name is LSP release. In a different distribution, it might be a different name, but definitely it will start or it will end with release. That's why here we use the release, and before the release we have asterisk and dash. Alright, so now we learned about the operating system and the version. Now let's learn about other things such as the users and the groups. So we can see the logged in user using the who command. So who command, you can see the logged in users. And here we have one user who is logged in. The name is user, and PTS means that the user is logged in remotely. Okay. And this is date and time, and this is the IP address. The IP address of the user, not the machine. The machine that the user is using to log in. We can also use W to show more details about what the users are doing. So here we can see more details. The column what, we can see what the user is doing. So the user has executed the W command. Also we can see the last logged in users using the last command. So in the last command, okay, we see the users that logged in recently. So we have two users who logged in remotely, user, and another one called Randa. Alright, so I hope there are questions. Let's go here and answer these questions. What's the name of the Linux distribution used in the VM? It was Ubuntu. What is its version number? We answered this. What's the name of the user who last logged into the system? We also answered this. What is the highest listening TCP port number? Alright, so we want to talk about the processes and the network connections that the processes create. For that, we use a tool named netstat. So netstat, these switches demonstrate how we use the tools or the options. So we were looking to list the TCP ports. So we used the -T, indicating we want to list TCP connections, and here we use -L because we want to list only the listening connections. So we have the listening and we have the established connections. We want to list only the listening connections. So -L and -T. And what other things we can list here? Let's see. Show the PID. Alright, so let's use netstat -tl. Okay, as you can see, we have the connections in the listen state. Well, we can get more details if you go back. So T-X So this command, for example, list the TCP connections, U for UDP connections, L for only listening sockets, P to show the PID of the process, and N to prevent the resolution of the IP addresses. So let's start, but this command alone doesn't answer the question. You can see here the highest port number is 3617. So why this command doesn't answer the question? Because if we execute instead again and -T only, this is the TCP established connection. So without the L, okay, we won't list the connections in listen state. We only list the connections in the established state. But with the L, we create the filter and we get this output. So surprisingly, this output doesn't have the port number I want. لازم okay, let's start -PL or -LPT. So L for listening connections, P for the PID of the process, and T for the TCP. So we can see here we have the dashes. We don't have details, so it means we will need higher privileges to get to execute this command. So sudo, we want sudo netstat -lpt. The password for the user is here. And now look here, we get the name of the programs running each one. Okay, let's use -N to prevent the resolution, and now we can see that the highest TCP number is this. Now previously, look at this. This is the process responsible for making the connection, or the process using this port as a listening port. Now if you go up, you can see the same process, but this time with the resolution enabled, localhost and the service. If we use the switch -N, we prevent the resolution of the IP, and therefore we get exactly the IP address, which is the local host, and the port number, and that's the highest TCP number. What's the program name of the service listening on that? We answer this. There is a script running in the background. Its name starts with THM. What's the name of the script? Now here we pivot into listing the running processes. So to enumerate the running processes, as we explained earlier, we use PS tool. The PS tool also has options which we can use to leverage the tool. So -E to list all the processes. In the PST format, to list all the processes, we use AUX. AUX are necessary for using PST. Okay. -F for full format listing. -J for jobs format, long format, user-oriented format. Pretty much basic command, easy to use. So we go back. We want to find out what is the script running in the background. So we're going to use PS AUX. So PS AUX has a huge output. We want to filter this. Let's go back. Okay, has the name THM. So here we're looking for a specific thing. To find this easily, we're going to use a filter grep THM. And as you can see, guys, we have two matching entries. Look at this. The user is Randa. Now Randa is running bash script. This is the full path to the bash script, as you can see here. Now what we can do, we can check on the permissions of the script. So ls-la home Randa. Look at this. This is the script, and now we look at the permissions. So there's a randa has read, write, execute on the script, and any user who belongs to the group randa again has read, write, execute on the script. So this translates into the fact that if you get access to the system as there's a randa, okay, you'll be able to do whatever you want with the script. But if you get access to another user, let's say it is data, and that user happens to be part of the group randa, you will also be able to modify on the script. So meaning, if you can control the behavior of the script by modifying its contents, you will be able to get shell as user randa and perform privileged escalation. That's one example scenario. Okay. So by now we answered the questions. Let's see if there are other things we can cover. So connections, processes. Another important aspect of enumeration during the post-exploitation phase is, as you can see here, we want to list the history of the commands. This is very important because command history might include trove of sensitive information, such as passwords typed into the terminal, usernames, API keys, other information that could lead to privilege escalation. So let's see here, history of sudo commands. So we look at the log authentication log file, or we look in the bash history file to find this. Let's go to the bash history and see. Indeed, guys, these are the commands that I executed. Also, we can look at the history of sudo commands in this log file. So we use a combination of cat and file processing using grep. So here the command is the command we want to we're looking for. Okay. Now also there is the configuration files. So configuration files come in various formats. Mostly they are in conf and text. If you are able to list the configuration files or search for a specific key in the configuration file, such as the string password, we'll also be able to, we might stumble upon sensitive information. Okay, now that is for Linux. Now let's switch to the Windows machine. So we're gonna terminate this machine and go on and switch the Windows machine. Let's see how it looks like from the Windows perspective. Okay, so let's say now instead of Linux, we get access to a Windows machine after the exploitation. Now, when you get shell access, it will be either PowerShell access or it could be CMD access. Now here it is PowerShell access judging by the prompt, PS. Now we can switch to CMD using cmd.exe, and we will switch to the command prompt. We can go back to PowerShell this way. Okay, now we start the enumeration process in the Windows machine. So what are the things we were looking for? We stated that earlier. First, we want to see the system information. And there are many commands that we can execute to retrieve system information, but the simplest one is system info. So here we'll load information about the OS, the version, the installed updates, and the hotfixes. Okay, scrolling up. So the OS name is Microsoft Windows Server 2019 Data Center, and this is the OS version. Again, guys, you can go out, search in Google, and see if there is a vulnerability for this exact version. If there is a vulnerability, you will look for an exploitable code to apply it on the machine, and therefore you escalate the privileges, hopefully. Here are other information such as the architecture, the time, date, so on and so forth. Scrolling down, the physical memory, the domain it's part of. So it's part of a worker group. It's not part of a domain, meaning there is no Active Directory. Here we have the hotfixes installed, the network cards, and as you can see, DHCP is configured, meaning that the machine is assigned an IP address automatically, not statically. Meaning this means that the machine doesn't act as a public server, because public servers need to have a static IP address. In order to achieve that, we disable the DHCP on these public servers because we want to have a static IP address on these machines to be accessed from. Okay, so now we learned the system information. Okay, next thing we want to learn who is the user that we have access to. That's the user. We can also execute whoami/group. Okay, priv. Look at this. These are the privileges of the user which is logged in. So why the groups didn't work? Let's see, groups. Yeah, these are the groups. The groups, among the groups we have, as you can see, the administrators group. The administrators group is a target all the time. So you also list the users who are part of this group. Okay, what are the things we're looking for here? Now these are the commands we can use to, multiple methods to get information about the system. Here we can use a WMIC, okay, to get information about the installed software. Let's execute that. Here we list the product name, the version, and the vendor. So if you learn about every installed app and the version of this app, we might stumble upon an outdated application, right? And therefore, if the application is outdated, we will be able to search for the vulnerability and a matching exploit. All right, so this command is running. Let's go here and see what are the questions. What's the full OS name? We answered this. What's the OS version? We answered this. How many hotfixes are installed on this Microsoft Windows system? There were around 30 hotfixes, I remember. Let's go up. So we have 30 hotfixes. What is the lowest TCP port number listening on the system? Alright, so here we are back to the concepts. We want now to learn about the network connections. Again, we use netstat. I'm gonna cancel this command because it's taking a lot of time. And looks like there are no apps installed. Not much, I mean. So, to learn about the network connections, again, we use the netstat. So in netstat, we have, again, switches or options. -A to display all listening ports and active connections, listening and established. Now -B lets us again find the binary or the executable involved in the connection, meaning the executable running the process and making the connection. N is used to avoid or prevent the resolution of IP addresses and port numbers, and O to display the PID of the process. So the question here is, what is the lowest TCP port number? So we want to list the current connections. That's that. So back here, I'm going to use -A, okay, and we're going to use -N because we want to prevent the resolution. We want to see numbers only. And that's it, I think, for this question. -N and -A. So netstat -N AN. Oops. Oh, I typed netstat 2 times. Okay. Netstat -AN. Wow, too many connections. All right, fine. So here we're gonna use the magic of filtering. So here we want to find out the connections in the listening state. So netstat -AN, that's true, but we're gonna pipe this into find string, which is the equivalent of grep in Linux. Find listening. And the output is way more easy to handle. These are all the connections in the listening state. We want to find the lowest TCP port number. So the lowest is, let's see, it is 22. What's the name of the program listening on that port? Now you want to find out the executable running this process. So to do that, we're going to use the switch -B. So back here, A and B, but we have nothing. It might happen, guys, if you want to find the binary, the output might not include the binary name. So let's use that in conjunction with -O, listing the PID of the process. Now this is the PID of the process. So if you don't see the process name, what you can do, you can take the PID of the target of the process and then use task list. So task list is the equivalent of PS in Linux. So the PID name is, let's see what process using the port 22. It's the process whose PID is 1608. 1608. Okay, so task list find string 1608. And indeed, guys, as you can see, it is the SSH service. Okay, that's for the Windows machine. There is another task here. It is DNS SMB and SNMP. Now here we didn't talk about this in the theoretical part of this video. So here actually we enumerate network protocols in order to find shares, files that are hosted on these protocols. An example is the SMB, server message block. It's used to host shares, right? So when we get access to a machine, if we list the shares, we might again stumble upon sensitive files that contain credentials. That's why we enumerate SMB, for example, using netshare. That's what we're gonna do in this task. So knowing that the domain name on the MS Windows server on the MS Windows server of IP is red team, use dig to carry out a domain transfer. What's the flag you get in these records? Okay, so here we want to enumerate the DNS records. Usually this step is performed before the exploitation. It's performed in the information gathering. So you know your target is redteam.thm and this is the server IP. So you perform a zone transfer, okay, to get the list of all of the DNS records of your target. But sometimes, let's say you overlooked this step in the information gathering, and now you want to do this step in the post-exploitation phase. So to do that, we're gonna leave the terminal running here. I'm gonna open a new terminal. Let's say a new tab, and use a command named dig. So I switch to information gathering and I use dig. So to perform zone transfer, we use this command. Let's copy that. Okay. So the target name server is given in the task. So we're asking this server, okay? We're asking this server about this domain name. Technically, we're asking it to do zone transfer. So the zone transfer for this domain name. And now we're able to retrieve all the DNS records stored in this DNS server. One of them is this subdomain. The subdomain contains a text record, and this is the flag of this task. Okay, what's the name of the share available over SMB protocol that starts with THM? So to get the information about the shares, we go back to the machine we got access to, and we issue netshare. And netshare will list all of the shares hosted on the server. We have this one, C users private. Knowing that the community string used by this SNMP service is public, use SNMP check to collect information about the MS Windows server of this IP address. Now, SNMP is the simple network management protocol responsible for managing the network events and devices on your network. So it might contain information about the configuration files, network events. So it's worth enumerating the protocol if there is a service running on this protocol in the machine. So to do that, we have several tools. SNB, I'm going to mention some. So we have 161. We have SNB walk, but in this task, we're going to SNB check as required. So to do that, we're going to execute this command. So we're going to take this and go back here. The path to the script is opt. So IP is given in the task. So you're asking the SNMP server what information it has about our devices, provided that we have the community string. No such file directory. Hint. Opt SNMP check. So we have here SNMP check, just the path of the script. As you can see, it's written in Ruby. Okay. As you can see, we get information about the server, the host IP address, the host name, and among the other information we have is the location, which has the flag. Now for Windows, there is nothing else. This is also easy. Okay, so that was today's video, guys. I hope you enjoyed the video, and definitely, guys, as always, I'm gonna see you later.